Hey, welcome back to Fam. I'm a physics. I'm a little dark here, but I have my camera in a weird angle because I want to show you something. In this video, or set of videos, we will talk about how to use graphs to solve problems. So essentially what we have is we have our set of patterns, and then based off of this pattern, because it only represents so much space, sample space that we use, our data points, what happens if we want to go beyond our data and figure out things that potentially predict what might happen, say, down in the future, or what happens if this pattern continues? And basically, we're going to look at what interpolating and extrapolating means when we deal with graphs. So basically taking a pattern and kind of moving forward with it. So, like I said, there will be a board game that I am introducing in this particular video. So I'm just going to show you quickly what it is. My voice is probably very soft right now, but this is what I have. It is called Zokin. It is one of my favorite games because it really messes up with your mind a lot because of so much thinking that you have to do, and you're thinking, oh my goodness. You do all the math and you still have to think when you're playing a game. Yeah, it's like work, right? It's like, I know, it's pretty crazy. But it's so fun, it's so interesting. It's Zolkin. It's based off a Mayan calendar. And I'll show you why that is in 1 second. So I'm going to take my whole, take this whole thing. I wonder if I can flip my camera around. Okay, so then if you didn't see the board game, hopefully it looks better now. Okay, this is Zolkin. It's probably backwards for you. It's based off the Mayan calendar, so I'm going to camera around to show you the board game. It's a very elaborate board. So if you take a look here, it is it's based off the Mayan calendar, and oh, I forgot one thing I should have here, which are these pucks. So essentially, there's a lot of wheels involved, which look really fun. And of course, as the calendar ticks, everything else ticks because everything takes time. So notice if I turn the middle wheel, every wheel around that will turn. Well, actually, you should turn this way. Yeah, I should turn this way because time is moving forward. Okay, so now what the interesting thing about this game is you have to plan all your actions in advance, because every day you tick the calendar over by once and things advance along the wheel. So let me just give me 1 minute to open this. All right, so here I got some workers here, and on your turn what you would do is you put a worker down, and I'm trying to figure out where it goes. So normally there would be people blocking your way, but in this case, if I'm the first person there, that's what I would put my worker. Okay, so what's going to happen is as the calendar ticks over, it represents the passage of time. So then notice after 1 day, notice my worker is along the wheel track now. So which means the next turn, if I decide to pull this guy off, I get this item here, which is a piece of wood. But if I and then say this guy, it might be, say, 3 corn. But if I wait longer, the more as time passes, notice the items that I get sweeter and sweeter. So for example, this guy, he's going to be able to get 9 corn or 4 wood. This guy can get all of these items over here, which of course they all get sweeter, right? So basically, I kind of have to plan out how the wheel's going to tick, where I'm going to end up, so I get the resources in time for me to build things that I want, which happens in the rest of the board. So there's a lot of planning involved. So basically, based off of the pattern, which is the calendar, I have to extrapolate. I have to read forward. I have to predict what's going to happen in the future. So that's the idea with these graphs that we're going to show us in a moment, is how to take a pattern and predict what happens based off this pattern, what's going to happen later on. Okay, so it's a cool game. It's one of my favorites. Okay, I'm putting this one away, so give me a moment. Okay, so everything's set up now. Everything is packed away. So now we are going to dive into this lesson. So again, because some of you and good amount of you know the slope y-intercept form, I am going to do this set of lessons using the method, assuming you don't know that, and assuming that you do know the y-intercept form. So this one is just the basic one, where let's say you didn't know what the slope y-intercept form is. which is the minimum expectation here. Okay, so I'm gonna break this lesson up into the two ways how you can interpret your graph. Okay, so interpreting your graph, the first method that we're gonna look at is interpolation. So what that means is assuming that you have a graph that you produce from your data values, estimating a value that is in between all of your data values. You estimate a value that is between data points on a graph. Okay, so what does that look like? And inter, if you notice, the word inter means within, kind of is what that is trying to show you. So let's take a look. To draw the graph below, we plotted the distance traveled every hour, then drew a line through the points. We can use interpolation to estimate values between two data points on the graph. Okay, so notice this graph, we have the time in hours and distance in kilometers. After 1 hour, this person traveled about 80-ish, 75 kilometers. After 2 hours, it was at roughly 150. 3 hours, almost 250, and so forth. Now, based off of our data points, we know exactly where the car, or how far the car has traveled after 1 hour, 2 hours, 3 hours. But what happens if we want to find, say, where the car was in between 1 and 2 hours? We don't have that data point, but based off of our graph, we may be able to read it and to pick out that point. So here we want the distance traveled after 2.5 hours, 1.5 hours, which we don't have the data point for, but we can estimate it using the graph that we have. And why is it called interpolation? Because it is in between our data values. Okay, so it's more precisely, it's between 1 hour and 2 hours. That's kind of where we're guessing where it is. So here, I don't like the symbol here. H is 1.5. I'm going to use X is equal to 1.5 hours. Okay. So if X is 1.5 hours, we're going to try to figure out what Y can be. So I'm going to zoom into this graph. Now, if you're writing this on paper, you might not have that luxury, but at least I get to show you what that looks like. So at 1.5, let's use a different color, maybe black. Okay, at 1.5 hours, which is right there, it intersects the graph right there on the red line and moving over. So if it helps you, draw these dotted lines here like that, and then making as straight as possible. Okay, if for you that would be reusing a ruler. Okay, so here we have imagine these dotted black lines here, and it's gonna intersect somewhere roughly along there. So it's like so that's roughly 120 kilometers, roughly. So it's not going to be very accurate, not very precise, but reading the graph like that kind of allows us to estimate that. So again, it's an estimate, so it's roughly 120 kilometers. Now for B, estimate the time it takes to travel 300 kilometers. Okay, so this time we're working backwards. We want to see how long it took us to travel 300 kilometers. So this is, since kilometers is recorded on the y-axis, we're saying if y is equal to 300 kilometers, what is x equal to? What is the time? Okay, so we're going to zoom in again. So here's 300. Okay, intersects our graph right there. And then what we're going to do is we're going to use a line, hopefully a nice straight line, using a ruler. For me, it will just be this. And I'm going to have that intersect my y-axis, and that's roughly 3.8 hours. That's roughly 3.8 hours. Not 3.75. 3.75 would be smack in between that blue line and the 4 line. I'm assuming that you can read your graph, but let's just make sure. Imagine this is 3, this is 4, and then halfway in between is 3.5. So this is 3.5, this is 4. In between 3.5 and 4 is 3.75. This line doesn't quite cross there at 3.75. So I said that's why it's 3.8. It's a little bit higher. So 3.8 hours. Okay, so I'm in fact going to break the video off here, and I am going to do extrapolation in the next video. Okay, so interpolation is basically looking in between your data values to figure out, okay, what could have happened in between. The next one, we're going to look at extrapolation, which is looking beyond your data values and seeing what that means, okay? So, thank you for watching. Stay tuned. I will see you next time on Fat Mama Physics, signing out.